To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to continue with the O-Level 2021 paper, that is paper 1, the MCQ type questions. So in the previous chapter I discussed the first 20 questions of that paper 1. Now I am going to start with the 21st question. Question number 21. A few ways of connecting 4 resistors of equal magnitude. So here you have to see 4 resistors equal magnitude are shown below. Of them, which one has the lowest equivalent resistance? So you all know what equivalent resistance is, and you all know the way of calculating equivalent resistance. Now there are 2 ways in which the resistors can be connected. If it is a series connection, you all know we add the resistance of each of the resistors. That will give you the equivalence resistance. But if it is a parallel connection, then 1 over R is equal to 1 over R1 plus 1 over R2. Then you take the reciprocal for the equivalence resistance. So there you can remember, students, if it is a series connection, the equivalence resistance will be the sum of all the resistors. Whereas when it is a parallel connection, the equivalence resistance actually becomes lesser than the individual resistors, because there we are taking 1 over R. So you can remember that. Then with that idea, if you look at all these, now let's say we will consider the resistance of each resistor as R. So they are all equal. So for the first one, if you calculate, here you can see the 4 resistors are connected in a series manner. So what is going to be the equivalent resistance? I'll take this as R1, then equivalent resistance is R. So what do you have? You will add R1 plus R1 plus R1 plus R1. I'm adding all R1 because we take these as the equal values. So then it's going to be equal to 4R1. That is the equivalence resistance. Is that clear, student? So the second one, if you take, what is going to be the resistance? Now here you can see this and this, they are in series. In between there is this resistor, this part, where 2 resistors are connected in parallel. So it is like this component with this component and this component, all 3 are in series. But in the middle, there is a parallel connection. So you can remember, if we want to find the equivalence resistance for that parallel connection, the middle part, how do you do? Let's say 1 over, I'll put R dash. So that is equal to 1 over R1 plus 1 over R1. You all know that is going to be equal to 2 over R1. So this R dash is equal to R1 divided by 2. But to find the equivalence resistance R, you need to add everything together. So in this one, like it's shown, you have this. I'll repeat that. So here you can see that is one single resistor. Then we have the 2 resistors connected in parallel and then another resistor. So this is R1. This is also R1. But these 2 you found the equivalence resistance as R1 divided by 2. So you need to add them together to find the final equivalence resistance. What is that going to be? R1 plus R1 by 2 plus R1. So that will be equal to what? 2R1 plus R1 by 2. Or we can say 2.5 R1. Now earlier we got the value 4R1. Here we have got the value 2.5 R1. That is for the second type of connection. Now here you all can remember, students, the third type of connection. If you look at it, the third connection of resistors, this is 1. Here the 3 resistors are connected parallelly. Now you can remember, I showed you all the working here for 2 resistors when it is 1 over R dash, 1 over R1 plus 1 over R1. So it becomes 2 over R1. Therefore, when you get the equivalence resistance, it is R1 divided by 2. When there are 2 equal resistors connected parallelly, the equivalence resistance become half. But here, there are 3 resistors connected in a parallel manner. All 3 are equal. Then what happens to the equivalence resistance? So here, this will become R1 by 3. I will do the calculation also. For the third one, you have like that. You have it this way. So this of course is R1. Now for this component, if you calculate 1 over R dash equals 1 over R1 plus 1 over R1 plus 1 over R1. So that is 3 over R1. The equivalence resistance equals R1 by 3. What I told you. When you have 2 equal resistors connected parallelly, the equivalence resistance is half. When you have 3 resistors equal in value connected parallelly, it becomes the resistance divided by 3. So here, if you want to calculate the equivalence resistance. Now this is R1 divided by 3. Equivalence resistance is what? R1 plus R1 divided by 3. So that is the value here. Then the last one. We have all 4 resistors parallel. Then you know it gets divided by 4. But just to show you all the working. Now the fourth one, we have all the resistors are connected parallel. Then 1 over R equals 1 over R1, or that is going to be 4 over R1. So that is R equals R1 divided by 4. Now can you see? The more resistors that are in parallel connection, the equivalence resistance decreases accordingly. When 2 are there, it becomes half. When 3 are there, it becomes 1/3. When 4 resistors of equal resistance are connected parallelly, it becomes R by 4. Is that clear? So you don't have to do all these calculations, students. This is for you all to recall what we have learned. I have done the calculations, but as you look at the diagram, you should be able to relate it. Even without writing all these, you can relate it. Now, if we look at the question, of them, which one has the lowest equivalent resistance? So, you were able to see that it is the last one. Here, everything added up. So, we got the value as 4R1. Here you can see we got the value as 4R1. Then we got it as 2.5R1. Then here 1.3R1, 1 plus R1 over 3. So that is even less. Here of course this becomes 0.25R1 or R1 divided by 4. So that is the lowest value. That is the fourth answer. You can see this is the fourth answer. Is that clear, students? So now that I have explained the calculation, when you look at the diagram, you all know series manner resistance gets added up. So 4 times R. Whereas parallel manner, it gets divided. That is when all the resistance values are equal. That you have to remember, students. If the value of the resistors are different, then of course you have to calculate it. Now this is easy to identify only when they say equal magnitude. Resistors equal magnitude. You have to keep that in mind. Is that clear? So with that, I'll move on to the next question. Question number 22. Consider the following organs. A is skin, B kidneys and C pancreas. You're familiar with all these organs. Of these, those that contribute to maintain homeostasis of the body is R. So here you have to observe homeostasis. What is homeostasis? Balance of the internal environment of the body. Even if there is a change in environment, then accordingly the body adjusts itself to maintain a balance between a particular range. So that is what we call as homeostasis. So you all know in homeostasis, amount of water in the body is regulated, balance of water. Then the level of glucose is regulated and also the temperature of our body. We are warm-blooded animals. Both birds and mammals are warm-blooded animals. So our body temperature has to be maintained. So there is a slight range between which it can fluctuate, but apart from that, it has to be maintained. Now if we consider the three organs. The first one is skin. Does that involve in homeostasis? Yes. Now you all know, I told you all about the temperature. The body temperature has to be maintained. Let's say if the temperature of the environment increases, then there is a tendency for the temperature of the body also to increase. To prevent that, what happens? You all can remember the blood vessels dilate so that there is lot of heat brought to the outer layers of the skin. At the same time, there is lot of sweat produced. When there is lot of sweat produced, the sweat has to evaporate. When that happens, the sweat absorbs heat from the skin. So like that, lot of heat is lost from the body so that the temperature can be maintained. So their skin is involved. At the same time, if you consider the decrease in environment temperature, then what happens? Our body also can lose heat. So to prevent that, what happens? One thing, the blood vessels constrict so that there is less blood supply to the skin. So because of that, less amount of heat is brought to the upper layers of the skin. At the same time, the hair on skin, it becomes erect. And when they become erect, the air is entrapped between the hair layer. And air is an insulator of heat. So because of that, it acts as a blanket which insulates the loss of heat from our body. So in both ways, skin is involved with regulating temperature. If you take the kidneys, what do they do? Now, they are involved with the water balance of the body. Normally, when there is lot of water in our body, at the same time, the environment is also like a rainy day. Then the environment, the temperature is also very less. You don't sweat a lot. Because of that, there is more water in the body. Then, of course, the kidneys produce more urine. More water is excreted from the body. At the same time, if the water content of our body decreases, on a very hot day, when you sweat a lot, then water is lost from the body. Then, of course, what happens? There is ADH hormone secreted by the pituitary gland that acts on the kidneys and they make the nephrons to reabsorb more water. So, the production of urine decreases on a very warm day when the water content of your body is less. So, either way, kidneys are involved with regulating the water content of the body. Then how about pancreas? Pancreas, you all know, it acts as both a enzyme producing organ and an endocrine gland. Now in the digestive system, pancreas produces pancreatic juice that is involved in digestion. That is one. At the same time, now when there is digestion taking place, when carbohydrates digest, there is lot of glucose in the blood. because the digested end products are absorbed into the bloodstream. So, in blood, there will be a higher amount of glucose. Now, glucose has a certain level, 80 milligram to 180 milligram per 100 milliliters of blood. If the blood glucose level is more than that, it is not good for the body. So, there what happens? The pancreas has the islets of Langerhans, which has the beta cells that produce insulin. Insulin converts glucose into glycogen or fat in the liver. The same way, if you don't have enough glucose in your blood, then what happens? There is the alpha cells in the islets of Langerhans of pancreas. They produce glucagon, that is also a hormone. The glucagon converts fats or glycogen in liver back to glucose, so that the amount of glucose is in blood increases. So, their pancreas is involved in the regulation of blood glucose level. So, here I have just written the factors. So, all three organs, skin, kidneys and pancreas, they involved in homeostasis. You have to remember that. So, if we look at the answers, only A and B, only B and C, all A, B and C. That is the answer. Is that clear, students? So, with that, I'll move on to the next question. 23. The graphs P and Q respectively indicate how the body temperature of the two organisms P and Q varies with the temperature of the environment. The organisms P and Q respectively can be. Now look at the body temperature, environment temperature. When environment temperature increases, the organism P, the body temperature does not change. That means it is a warm-blooded animal. Warm-blooded animal or homeothermic animal. Their body temperature does not change irrespective of the environment temperature. But if you take organism Q, you can see when the environment temperature increases, the body temperature increases. So, it is a cold-blooded animal. Cold-blooded animal or poikilothermic animal. Now, warm-blooded animals are both mammals and birds, mammalia and aves. Whereas pisces or fishes, amphibians and reptilia, that is reptiles, they are all cold-blooded animals. So, that is how you need to look for the organisms. Organism P and Q respectively are. So, P should be warm-blooded and Q should be cold-blooded. So, warm-blooded and cold-blooded. Then, if you look at the first answer, ox is a mammal and bat is also a mammal. When both are mammals, both are warm-blooded animals. Then, that's not the correct answer. Fowl and tortoise. Fowl, yes, it's a bird, aves, so warm-blooded. Tortoise is a reptile, so that is cold-blooded animal. Here we need to find again similar to P and Q, warm-blooded and cold-blooded. So, that is a correct answer. Then look at the third one. Elephant is a mammal and duck is a bird. So, both are warm-blooded. Then fourth one, frog and tilapia. Frog amphibia, tilapia fish. So, both of them are cold-blooded animals. The correct answer is going to be fowl and tortoise. Fowl is a bird, warm-blooded. Tortoise is a reptile, cold-blooded animal. I am sure you all can understand that. So, with that, the next question. Question number 24. In which order does the brightness of the bulb decreases in the circuits A, B and C? Now, say brightness, what does it depend on? Brightness depends on amount of current flow. Brightness is high when the current flow is high. Now, current flow is high when resistance is less. Resistance is less. That is depending on the resistance of the conductor where the bulb is connected. So, that is how you have to look at. Now, if you look at all three diagrams, in the first one or circuit A, there is one battery, B also one battery, C also one battery. So there's no difference. And the bulb is the same. There is only one bulb in each circuit. But there is a resistor in circuit B and the way the circuit C is connected is different. Now you have to look at it. If you look at this, there is the resistance of the bulb and there is only one path for the current to flow. So then bulb will light and there will be a certain brightness depending on the resistance. Now here if you take B, there is one bulb and one battery. So the same amount of voltage, but here you can see there is a resistor. So that means the resistance, equivalent resistance of this circuit is higher. Here only bulb, here bulb and a resistor. So because the resistance increases, the current flow decreases. So then brightness will be less. So compared to A, the brightness of B will be less. Is that clear? So A will be more brighter than B. At the same time, if you look at C, now here what happens? There is the battery, then there is the bulb, but there is a conducting wire in between. Now when the current comes to this point, it will have to divide. It will be distributed depending on the resistance. Now here, this conducting wire has less resistance compared to the one with the bulb. So what will happen? More current will flow through this, less current through the bulb. So because of that, the brightness of the bulb will be very less. Is that clear, students? Since there is very less resistance, only the conductor, there will be more current flowing through that conductor and only a small amount of, very small amount of current will flow through the bulb. Is that clear? So because of that, the brightness of C will be the lowest brightness. Here the normal resistance of the bulb. Here in addition to that, the resistance is higher. Here it is the bulb, but more of the current will flow through just the conductor. So you have to look at all the factors. So the order of brightness, the least bright will be C, then B, and the brightest will be A. If you look at the answers, A is more than B, B is more than C, A is more than C, C is more than B, B greater than C, C greater than A, C greater than A greater than B. So the correct answer is the first one. A greater than B, B is greater than C in brightness. Is that clear, students? So consider all the factors. Brightness depends on the current flow depends on the resistance. But in an instance like this, if there is a path that has very less resistance, current will flow through that compared to the path with the bulb that has a resistance. Due to that also, the brightness can decrease. Have to keep all that in mind. With that, students, I'll move on to the next question. Question number 25. Some information regarding an element are as follows. Has several allotropic forms and one allotropic form conducts electricity. So you all know, students, when we discuss the periodic table, there are the metals, non-metals and metalloids. So metals, magnesium, sodium, they do not show allotropic forms. But the non-metals like carbon, sulfur, oxygen, all of them exist as allotropic forms. You can remember carbon, diamond, graphite, coal, charcoal, all these are fullerene, all are different allotropic forms of carbon. Sulfur, you have the crystalline sulfur, amorphous sulfur. Even the metalloids, silicon shows allotropic forms. So usually the non-metals and the metalloids exist as allotropes. So now if you look at the answers, like I said, carbon. Carbon, yes, it shows allotropic forms. And out of that, graphite is a very good conductor of electricity. Why? In graphite, one carbon is bonded to 3 other carbons. There, they form a hexagonal shape where 6 carbons are bonded together and they form a sheet of carbon. And in each carbon, there is a free non-bonded electron. The free electrons form a cloud. And between the clouds, electron clouds of 2 sheets of carbon, there is a very weak interaction. That is why graphite is a lubricant. At the same time, due to the presence of these electron clouds, they are very good conductors of electricity. So, carbon has allotropic forms, yes, and it conducts, one allotropic form conducts electricity. Oxygen, yes, it has allotropic forms. Oxygen and ozone, O2 and O3. O2 and O3, ozone, oxygen and ozone, allotropic forms. But they are both gases, they don't conduct electricity. Sulfur, yes, like I said, crystalline, the yellow color crystalline sulfur, white color amorphous sulfur. But they don't conduct electricity. Iron is a metal, conducts electricity, but does not have allotropic forms. So, the correct answer is carbon. Carbon. It shows both the properties, several allotropic forms and one form conducts electricity. Is that clear? So, you have to look at both the characteristics given there. I am sure you can understand that. With that, the next question. Question number 26. Some functions of the human brain are given below. So, when we say human brain, students, you all know it has 3 main parts. The cerebrum, which is divided into 2 hemispheres, then the cerebellum and the medulla oblongata. All 3 together is the brain, and different parts have different functions. Now, if you look at the functions given there, A, reception of senses. Receiving senses is done by the cerebrum, that you all know, cerebrum. Cerebrum, high order skills like thinking, memory, all those are controlled by cerebrum, and also receiving the senses, perceiving the senses, all that is by cerebrum. Then B, maintaining the balance of the body. Maintaining the balance of the body is done by cerebellum. You all know that, cerebellum. Cerebellum controlling voluntary muscle activities, maintaining the balance of the body, all that is by cerebellum. Then the C is controlling the rate of heartbeat. That is done by medulla oblongata. Heartbeat, medulla oblongata. Now, medulla oblongata, respiration, rate of heartbeat, and also you all are familiar with the involuntary reflexes. The cranial reflexes like vomiting, sneezing, those are also controlled by the medulla oblongata. So, out of these, of the above, cerebellum controls, we said, maintaining the balance of body, that is B. Only A, only B, only A and B, only B and C. The answer is only B, the second answer. Is that clear, students? So, with that, I'll move on to the next question. Question 27. Consider the following statements. A, the rate of a reaction increases when the temperature increases. Yes, rate of reaction depends on different factors. One is the temperature. When temperature increases, rate of reaction increases. When surface area of reactants increases, the rate of reaction increases. You have a chunk of something and you have tiny pieces. You have powder. The rate of reaction with powder will be higher compared to the large piece. And the small pieces will have the rate in between the two. So, that is when surface area increases, the rate of reaction increases. Then the concentration of reactants. When concentration increases, the rate of reaction increases. And also the catalyst increase the rate of reaction. Now, all these, the temperature, then the concentration and the surface area, all are related to the collision between reactant particles. Now, when there is more collision, then there will be more reaction. That is how the rate of reaction changes. and depends on these factors. Now if we look at the second one, the kinetic energy of reactant particles increases when the temperature increases. That is also correct. Thermal energy is the kinetic energy in particles. So that means the movement of particles increases. If the movement of particle increases, the number of collisions in a unit time increases. So because of that, the rate of reaction increases when you increase the temperature. So both the statements are correct. Of these, both statements A and B are true, yes. Statement A is true and statement B is false, no. Both statements A and B are false, no. Statement A is false and statement B is true, that is also not correct. So the correct answer is both statements A and B are true. The rate of reaction increases when the temperature increases, correct or true. And the kinetic energy of reactant particles increases when the temperature increases. That is also true. So with that, I'll move on to the next question. Question number 28. Which of the following phenomena cannot be explained by the Archimedes principle? What is Archimedes principle? When there is an object fully or partially submerged and floating in a fluid, the upthrust exerted by the fluid is equal to the weight of the fluid displaced by the object. So that is Archimedes principle. So there, if you have a liquid and in that if there is an object floating like that, now here the weight of the object, that is the upthrust exerted by the liquid, weight is equal to upthrust when it is floating, and also that is equal to the weight of fluid displaced. So here of course if I say water, it is the weight of water displaced by the object that is submerged in the water. Is that clear? So as examples, the first one, a ship cruising in the sea sinking more when entering a river. Yes, you can explain that using Archimedes principle. Seawater has higher density. The river water has less density. So when the density of the fluid is less, the upthrust exerted is also a little less. So because of that, the object sinks more. When the upthrust is less, object sinks more. When the upthrust is higher, the object floats more. You all can remember that. So first one can be explained. Then the second one, this can be explained. A balloon filled with helium gas moving upwards through air. That is also correct. Now if you have a balloon like that, now this is helium gas. There is upthrust exerted by the air. So this is air. Helium is less denser than air. Because of that, the upthrust exerted will be higher. So the helium balloon will move up. That is also correct. When we say fluids, it can be liquid fluids and gaseous fluids as well. Air also exerts an upthrust. You all have to remember that. Then the third one, floating of sunk orange seeds in a glass of orange juice when dissolving sugar. That again, density. Normal water, density is less. When you dissolve sugar, the density of water increases. So when the density increases, the upthrust exerted by the solution increases. Therefore, the seeds start floating. But initially, the upthrust exerted by water on seeds is less. So that's why they sink. But sugar solution exerts more upthrust, therefore the seeds float. So that also can be explained using the Archimedes principle. Fourth one, lifting a large mass by a hydraulic jack by applying a small force. What is a hydraulic jack? The system is a hydraulic press where there is transmission of pressure by fluids. So there, of course, it is not related to the Archimedes principle. You have a system like that where you have a thin arm and a broad arm. So here we apply a force. that will be transmitted as pressure through the liquid that will help to lift a particular weight. So here of course it is hydraulic pressure. Hydraulic pressure transmission. So that is not explained by the Archimedes principle. So the answer is lifting a large mass by a hydraulic jack by applying a small force. That is the answer. Is that clear, students? So with that, I'll move on to the next question. 29. The diagram shows a cross section of a cylindrical concrete ring kept on a flight of steps. So here it is shown in the diagram. Here you can see a concrete ring. There is a flight of steps. There is a person there. Indicated as A, B, C and D are 4 points at which force can be applied by a man to roll it to the upper level. So these are A, B, C, D, the points where this person, this man can apply a force to roll it to the upper level. What is the point at which force can be applied on the cylinder in a suitable direction to roll it up with the lowest force? So here when you say rolling, it is going to turn like that. So here what is the concept? Turning effect of force. When we say turning effect of force, then there is momentum. Moment of force. Moment of force. What is moment of force? The force applied into the distance. This is the perpendicular distance between the point of application of force and the axis of rotation. Now here if you look at this diagram, this is going to be the axis of rotation. That is the axis or point of rotation. We here will say point of rotation. Now when this distance from the point of rotation increases, the force applied will be less. If you draw a line from A to this, I'll use different colors. Then from here to here, then let's say here to here and here to here. Now look at the distances. Even just by looking also you can easily identify. If you take from this point to A and this point to B, they almost look the same. But you can see this point to C and the rotation point of rotation to D, those are small distances. The distances are less. When the distance is less, you need to apply more force so that you can apply the required moment of force to rotate the object. So the points can be either A or B. Unless you really exactly measure it, you cannot decide. So because of that, for this particular question, there were 2 answers given. Both point A and B were considered correct. But you all know the concept, students. When you have the distance more, the moment of force is more, then you can easily rotate the object with a lesser force. Is that clear? So there, the more distance is from the point of rotation to A or point of rotation to B. So both answers are correct. What I will do is I will mark both the answers A and B. So here you have to remember there are 2 answers. 1 and 2. Because here you can't really measure and say which is more and which is almost the same distance. Is that clear, student? So that is how you have to select the answer for this question. You have to consider the distance, because when you say rotate to the next level, it is the turning effect. So that means there is moment of force involved. Moment of force depends on the force and the distance from the point of rotation and the point of application of force. When the distance decreases, the force will increase. When the distance increases, the force will decrease. So you need to apply a certain moment of force to rotate this object. So to decrease the force, you have to increase the distance as much as possible. So points A and B give the highest distance. Is that clear, student? So with that, I'll move on to the next question. This is question number 30. When thin iron wool is heated, it instantly burns. But though an iron nail is heated till red hot, it does not undergo a considerable change. What conclusion can be drawn from these observations? So you have a wool, iron wool that reacts on heating. But if you have an iron nail, no reaction. What is the difference? When you have an iron wool like that, the surface area is very, very high. So because of that, the rate of reaction is high. Why is that? When the surface area is high, more reactant particles are exposed to the oxygen. So because of that, it reacts faster. Here, of course, less surface area, less exposure of the reactant particles, so less collision, almost there is no reaction. So the first one, iron wool acts as a catalyst. No. Iron wool and iron nail undergo reactions different from each other. No, because they are both iron. The composition of iron wool and iron nail is different from each other. No, they are both iron. So the same composition. Fourth one, the rate of a reaction depends on the physical nature of the reactants. That is correct. So here I told you all surface area. Surface area or physical nature. So the fourth answer is the correct one. The rate of reaction depends on the physical nature of the reactants. Is that clear, student? Question number 31. In 2011, the number of elephants in Sri Lanka was 5,879. What is the most suitable biospherical organizational level to denominate that number of elephants? Look at the answers: species, population, community, ecosystem. We will just go through all these organizational levels. If you look at this diagram, students, now you all know there is the species, that is the organizational level of the hierarchy of classification, where you have organisms that belong to one species, means they are similar organisms that can interbreed and produce fertile offspring. They are known as species. So from a species, if you take a particular organism, here you can see an individual living in a particular environment. So that is an individual. Just it can be a plant, it can be a microorganism, it can be an animal. Just an individual organism. Then if you take the next level, that is the population. Now when we say population, it is the number of organisms belonging to a specific species living in a certain time period in a particular area. You have to consider all that. They have to be the organisms belonging to a certain species, just one species, in a certain area during a certain time period. That is what we call as population. So here, if you can take this organism, although all of them in that particular area within a certain period of time, the same species is population. Then if you go to the next level, which is a little bit more complicated, it is the community. When we say community, different populations. Now here see, you can see different plants, different animals. There are different populations of all those. Different animals and plants. All of them together and the interaction between them is the community. Then if you take the ecosystem, that is even more complex. That is where you have the interaction between the communities, that is the living organisms as well as the non-living component. All together is ecosystem. Then we have the biosphere, that is if you take the earth, you have the hydrosphere, lithosphere and the atmosphere. In all those places, wherever the living organisms inhabit, that is wherever the living organisms live in places of the biosphere or of the earth. I'll repeat all that. So the next level is the biosphere. That is the hydrosphere, the lithosphere and the atmosphere of the earth, where there is the living organisms. Those areas together is known as the biosphere. Is that clear, students? So as you go from the individual to population, then to community, ecosystem and biosphere, the complexity of the level increases. Is that okay? So now if we try to answer the question, you can see here in 2012, the number of elephants or one species in Sri Lanka, a particular geographical location, was 5,879. So a time period, a geographical location and one particular species, organisms belonging to a particular species. Then you all know it has to be population. So the answers, species, population, community, ecosystem. Answer is population. So with that, I'll move on to the next question. Question 32. Select the correct option with regard to an NPN transistor. So they have given the options base, emitter, collector, whether they are the N terminal or the P terminal. So before I answer this question, I'll move on to the next slide where I have put the two diagrams so you all know. Now if we take the transistor, there are two PN junctions. So then you can have two ways, NPN and PNP. So here you can see PNP transistor arrangement. So PNP, there is the emitter that emits the charge carriers, collector that collects the charge carriers, and base that controls the flow of charge carriers. So here P is the emitter, N is the base and collector is again P. And carriers, the holes flow from P to collector P, that is emitter to collector, and the direction of the current flow is also from emitter to collector. That is why we have the symbol like that. You can identify the base that is in the middle. These two are the emitter and collector. Where you have the arrowhead is the emitter. And the arrowhead shows the direction of the current flow, emitter to collector through the base. And here it's going to be the PNP transistor. So collector and emitter are P terminals, base is the N terminal. On this side, here we have the NPN transistor. Emitter is N, base is P, again collector is N. So when it is N, charge carriers are electrons. Electrons flow from emitter to collector. Therefore, direction of current flow is from collector to emitter. So if you look at the symbol, you can say base is in the middle, emitter is identified by the arrowhead. So that is the emitter and this is the collector, and the direction of the arrowhead shows the direction of the current flow from collector through the base to the emitter. That is the NPN transistor. So this is the basic information related to PNP transistor and NPN transistor. Now based on that, it's easy for you all to answer the question as well. Now if we look at the question, select the correct option with regard to an NPN transistor. You can see base will be, if it is an NPN transistor, base will be P. Emitter and collector, they have to be N. So the first option, base P, emitter N, collector N, that is correct. Second one, base N, emitter P and collector N, no. Third one, base P, emitter N, collector P, no. And also fourth one, base N, emitter N and collector P, that is also not correct. So the correct answer is the first answer, where you have the base P, emitter N and collector N. Is that okay? N, P, N. Middle one, middle terminal is the base. So when it is N, P, N, P is the base. Like that also you can identify. Is that clear, student? So with that, I'll move on to the next question. Question number 33. the situation of transverse wave traveling on the surface of water at a certain moment is shown in the figure. The amplitude and the wavelength of this wave respectively are. So that is the question. You all are familiar with waves, students. Now there are waves that need a medium to travel. Now here it is on the surface of water. So you all know it has to be a mechanical wave. And mechanical wave, there are two types of waves. One is the transverse wave. The other one is the longitudinal wave. If the direction of the wave and the direction of the movement of particles of the medium are perpendicular, then it is a transverse wave. That is what is given there. Whereas the longitudinal wave, you all know the direction of the wave motion as well as the direction of movement of particles of the medium are both parallel to each other. So that is a longitudinal wave. So here water waves is an example of a transverse wave. Now if we plot the motion of the particles, then you will get a wave motion like shown in this diagram. And then you all know, students, there are certain physical properties for a particular wave. They want you to identify two of them, amplitude and wavelength. Now if we look at the graph, the plot given to you all, here you can see this is the distance. Distance moved by the particles of the medium. Now here you can see what is marked. This is the waveform that is shown here. So you can see this is a transverse wave and this part is the crest. Here also you have a crest. Then here we have troughs. So like that, when you have one crest and one trough together, that is one complete wave. So in this particular diagram, they have shown two waves. This is one wave. What we have here is one wave. So here you can see there is the second wave. There are two waves shown and you know this is the crest and that is the trough. So if you take the particular wave, the maximum displacement shown by a particular particle during wave motion is known as the amplitude. That is the first one. Amplitude is the maximum displacement. So here if you take this line, from there the maximum displacement that is marked as 4 centimeters, here you can see is the maximum displacement. The same way from here to here also the particle shows a maximum displacement of 4 centimeters. But they are in opposite directions. You can remember that. So the amplitude has to be 4 centimeters. Then what is the wavelength? The second one we need to identify is the wavelength. Now wavelength is the distance between two particles which are adjacent to each other that exist in similar motion. Now here if you take this particular particle, it's going to move that way. But this particle, it's going to move downward. So they are not in similar motion. But if you take this one, that particle is again moving upwards like that. So this and this, these two particles are in similar motion. Whereas if you take, let's say, this particle and this particle, they are also in similar motion. Or else this particle and this particle, yes, similar motion. This particle and this particle, that also similar motion. So you have to consider one of those lengths. Now here you can see this is marked as 5 centimeter. So if you consider the position from here to this part where I have drawn this line, that length. Now this part is marked as 5 centimeters, but here you can see from here to here, it is double the length. So if this is 5 centimeters, this whole length has to be 10 centimeters. So wavelength lambda should be 10 centimeters. You can see that. Now this part is 10 centimeters. Even if you take the length between these 2 points, that is also going to be 10 centimeters. So amplitude is the maximum displacement, 4 centimeters, and wavelength lambda is 10 centimeters. In addition to that, you are familiar with other physical quantities as well. The frequency, the number of waves or number of cycles that occur in a unit time. Normally the unit will be hertz. So that is the frequency. Then the period, you all know, if you take one wave, the time taken for the completion of one wave is considered as period. that is capital T is the symbol of period. And also you all know the speed of waves. So their frequency is f, wavelength lambda. If you take the speed is equal to wavelength into frequency, f lambda. You all are familiar with all these equations. But here, in this question, we need to calculate or find the amplitude and wavelength. Like I told you all, the amplitude is 4 centimeters and wavelength 10 centimeters. Now, if you look at the answers, first one 4 centimeter and 5 centimeter. It's not correct. 4 centimeter and 10 centimeter? Yes. Third one 5 centimeter and 4 centimeter? No. And fourth one 8 centimeter and 10 centimeter. That is also not correct. Now here students, you all have to be careful just because they have marked this as 5 centimeter. Although you know the concept, when you are in a hurry, you might just directly look at the value given there, 5 centimeter, and there is a chance that you can mark it as the answer. But you have to think carefully. So you know that the length of one complete wave is the wavelength. So it has to be 2 times this 5 centimeter, that is 10 centimeters. And the correct answer is 4 centimeter and 10 centimeter. And you have to remember this order also, amplitude and wavelength. So amplitude 4 centimeter, wavelength 10 centimeter. Is that clear, student? So with that, I'll move on to the next question. Question number 34. Which of the following statements is false about electroplating of iron? So here, if you look at the question, false about electroplating of iron. Now, you are going to electroplate an iron object with a certain metal. Then you all know the conventions that are followed in electroplating. Now, here I have shown an electroplating, the electrolytic cell. So, there what happens? You have the batteries, we supply current. The positive terminal is connected to this particular blue color electrode. So, that becomes the positive electrode. Whereas the negative terminal is connected to this, that becomes the negative electrode. So, what happens is the negative ions, the anions go towards, I'll repeat that. The positive ions move towards the cathode and there they undergo reduction. At the same time, the negative ions move towards the anode, they undergo oxidation. So that is how the electrolytic cell functions. That is why the positive electrode is the anode and the negative electrode is the cathode. So, if you want to electroplate a particular metal onto an object of iron, the metals are positive ions. So, positive ions undergo reduction at the cathode. So, that means you need to connect this iron object to the cathode there. Iron object has to be the cathode. And the metal that is going to be coated has to be the anode. And this electrolyte solution needs to have the iron of that metal. Let's say if you are going to copper plate iron, the iron object has to be the cathode, copper has to be the anode, and we can use copper sulfate as the electrolyte solution. So that there are copper ions in the electrolyte solution. And also, if you want a very efficient electroplating or high quality electroplating, normally we need to use a less concentrated electrolyte solution. The concentration of the electrolyte has to be less, and also we should provide or supply a small amount of electricity, low electricity over a longer period of time. That is, if you do the electrolytic process very slowly. If the electroplating is carried out very slowly, then it will be high quality electroplating. So that is what you need to consider regarding the electroplating of iron. Now if we look at the answers, an aqueous solution of a compound of the metal that is electroplated should be the electrolyte. That is correct, like I said. Then the electrolyte should be in high concentration for quality electroplating? No, that will not give a high quality electroplating. So that is false. Iron should be made the cathode of the electrolytic cell. That is also correct. And then the current used should be a direct current. That is also correct. We use a battery here. We need to provide direct current. So continuously there will be current flowing. The terminals have to be the same. The current has to flow in the same direction. You cannot alternate the current. Then cathode and anode will change. That is not going to work. So it has to be direct current. That is also correct. So the answer or the false about electroplating of iron is the electrolyte should be in high concentration for quality electroplating. That is the false statement. Is that correct, students? So with that, I'll move on to the next question. 35. A conical flask containing aqueous hydrochloric acid is kept on a sensitive balance. Pieces of limestone were added to it in excess. Which of the following graphs indicates how the balance reading varies against time after the addition of limestone? So here we have a platform balance like that. You have a conical flask. We have a conical flask with a solution of hydrochloric acid. So there is hydrochloric acid, HCl aqueous, and this is the balance. So initially you get the reading for the HCl and the conical flask together. Then to that we add calcium carbonate. As you add calcium carbonate, it will be the weight of calcium carbonate, HCl and the conical flask all together. But when they start reacting, what happens there? Calcium carbonate reacts with hydrochloric acid, giving rise to, I'm just showing you all what happens there. If it's an equation, you all have to write it in a line. So here, of course, it is going to be calcium chloride plus carbon dioxide plus water. And this carbon dioxide will be evolving of or liberation of carbon dioxide. So because the product is evolved, what will happen to the mass of the mixture? Initially you have the reactants. As the reactants become the products, carbon dioxide will be evolved and the reactants are going to be used up. So the mass will decrease. The weight of the mixture will decrease. That means the balance reading has to decrease with time. And after that, after all the reaction is complete, you will have the remaining products, or if there is an excess of one of the reactants, that will also remain. So there the mass will become a constant. So the balance reading will become constant after the completion of the reaction. So if you look at the graphs, first one, the balance reading with time does not change. That is not possible. That means there is no reaction. Then the second one, the balance reading increases and then becomes constant. That is also incorrect, because then it's like you are adding something and then finally the constant value here, but carbon dioxide is being released also. So due to the reaction, a product is being released. The third one, again the balance reading increases and becomes constant. But when you compare 2 and 3, this is a straight line increase, gradual increase. Here it is a varying increase, but still that is also incorrect. Then the fourth one, the balance reading decreases and then it remains constant. That is of course correct. Is that clear, students? So that is the answer. Why? Initially you take calcium carbonate and HCl together, you get the total mass of the mixture, that is the balance reading, and as they react, carbon dioxide will evolve, the reactants are being consumed, so then of course the balance reading has to decrease, and when the reaction is complete, it remains constant. Is that clear? So with that, I'll move on to the next question. Then question number 36. The number of turns in the primary coil and the secondary coil of a transformer are NP and NS respectively. The voltage differences of the primary coil is Vp and the voltage difference of the secondary coil is Vs. What is the correct relationship between the numbers of turns and the voltage differences? You all know this relationship. So, you can find the answer from here itself. You all know the function of a transformer. You have the input or the primary coil, then the output or the secondary coil. The ratio between the number of turns in the primary and the secondary coil is equal to the voltage difference of the primary coil and the secondary coil. So, you need to find the correct relationship. Vp over Vs equal to Np over Ns. That is correct. Vs over Vp, Np over Ns, no. Secondary is on top here, primary is on top here. That is not correct. Vs into Vp equals Ns into Np, no. Vs into Ns equals 1 over Vp into Np. That is also incorrect. So, the answer, the correct relationship is the first one. Primary potential divided by secondary potential is equal to turns of the coil in primary, number of turns in the coil of secondary. So, that is how you have to select the answer. Is that clear, students? So, with that, I'll move on to the next question, 37. Questions 37 to 40 are based on the information given in the following table. Information relating to the method of obtaining energy, lighting devices and cooking equipment used in 4 houses A, B, C and D are given below. So, look at the table. House A, B, C, D. Then the second column, method of obtaining energy. Third one, lighting device. And fourth one, cooking equipment. So, house A uses solar cells as to obtain energy, uses CFL bulbs for lighting and LP gas cooker for cooking. B, National Electric Grid is used as the method of obtaining energy. Filament bulbs are used for lighting and electric heater and cooker are used for cooking. C, electric generator is used to obtain electricity. Fluorescent lamps are used for lighting devices and kerosene stove is used for cooking. Then D, biogas unit is used to obtain energy, biogas lamps for lighting device and firewood hearth as the cooking equipment. Now related to this, you can see some of these methods are energy efficient, some of them pollute the environment. So you need to consider all that and you have to answer the question. We'll look at the questions first. 37. For the energy obtaining method of which house is only a non-renewable energy source used? Non-renewable energy source. Now, solar cells is renewable energy. Solar energy is renewable energy. Then, National Electric Grid, it is from the water or hydropower plant, or it can be thermal power plant, coal power plant. So, there it can be any form. If it is hydropower plant, if it is a waterfall, that is a natural resource. But otherwise, you have to consider. Electricity generator. Now, electricity generator has to use a particular fuel. Now, this fuel is a non-renewable energy source. Then C is using a non-renewable energy source. House D, biogas unit. So, biogas is actually from the organic waste materials from the household, the kitchen waste, the excretory materials of organisms, all that is used. So, that also can be obtained naturally. But this one, electricity generator, needs a fuel. So, that particular fuel is a non-renewable energy source. So, for the energy obtaining method of which house is only a non-renewable energy source used, that is this one. So, there the answer is C, A, B, C. Is that clear? So, here electric generator uses fuel which are non-renewable. Then the next question, the same table, introduction, everything is given. Look at the question 38. Which houses use the lighting devices that largely contribute to pollute soil and water when improperly disposed to the environment? Now here, if you look at the different lighting devices, CFL is energy efficient, but it is compact fluorescent lamp. Now, fluorescent lamps usually give out mercury. Mercury is a heavy metal that is a pollutant. It can pollute the soil, it can pollute the water bodies. So, that will give rise to pollutants if improperly disposed. If you properly dispose it, no problem. But if you improperly dispose it, it will give mercury. So, here this gives out mercury as the pollutant. Then you have the filament bulbs in house B, that is filament, tungsten filament normally. That of course, it's not a pollutant. So, you have to dispose of them properly. There is glass and all that. But compared to CFL, the amount of pollutants is less. Then the third one, C, fluorescent lamps. Again fluorescent. So, that is also mercury as pollutant. So, biogas is a greenhouse gas. Here, the biogas is being used. So, there of course, it's not going to pollute the environment if you improperly dispose of it. So, that particular concept needs to be considered. Improperly disposed. So, when improperly disposed, CFL and fluorescent lamps can give out mercury. They do release mercury to the environment. So, because of that, they pollute the environment. So, the answers have to be A and C. If you look at the combination, A and C, A and D, B and C, B and D. It has to be A and C. A and C. Is that clear? Because they give out mercury. CFL, compact fluorescent lamps, and fluorescent lamps release mercury to pollute soil and water when improperly disposed. Is that okay? So, with that, I'll move on to the next question. Question number 39. Again, the introduction and the table are given to you. Which house uses the cooking equipment that minimally contributes to pollute air inside the house? Minimally contributes to pollute air inside the house. Again, you have to look at the answer. Pollute air inside the house. Now, LP gas is a hydrocarbon. When hydrocarbons burn, there is carbon dioxide and water vapor given out. CO2 and water vapor are given out. LP gas cooker. So, CO2 can pollute the environment. Electric heater and cooker, there is no such thing because we are not burning anything. We are using electricity. There is no fuel burnt, combustion of fuel. Because of that, none of these gases or vapor, water vapor is not released. Again, kerosene stuff, yes. Again, CO2, H2O, and you all know with kerosene, sometimes you do get that fume also, the black color fume, and it can give out that smell. So, all those can pollute the air inside the house. Firewood hearth, yes. Again, carbon dioxide, water vapor, and soot also, that is carbon, soot. All that is given out. So, there it is all polluting the air inside the household. So, the method that does not pollute is the electric heater and electric cooker. That is B. So, here the answer is B. A, B, C, D, B. Is that clear, students? So, with that, I'll move on to the last question. Question number 40. Again, the same introduction and the table is given to us. The 40th question. What is the house that has taken most practical solutions to the electricity and fuel crisis? So, for both. Here you have to see solar cells. But here they use CFL bulbs and LP gas cooker. CFL bulb needs electricity, but solar cell is used to provide the electricity needed. But they are using LP gas cooker. So that is a fuel. They have said electricity and fuel crisis both. So here LP gas cooker is the fuel. Then national electricity grid that needs the fuel and different electricity crisis that is involved with that. And also electric heater, again they are using electricity. For filament bulbs and electric heater, both electricity. So they are maximum using electricity, which can lead to electricity and fuel crisis. Housey electric generator, they are using the electric generator, which again uses fuel. And also fluorescent lamp, okay, less fuel electricity consumption, but still they are using the electricity generator. And kerosene stuff, that is again a fuel. So those are all leading to or contributing to energy and fuel crisis, electricity and fuel crisis. Biogas unit, they are producing their own electricity, biogas lamps and firewood. So that does not relate to electricity and fuel crisis. So because of that, the answer is the household D. A, B, C, D, the fourth. Is that clear, students? So with that, I have come to the end of this paper 1. MCQ type questions. You saw that they are from all different lessons, and the last 4 questions are related to biosphere, energy crisis, the environment, problems, those things. So normally all are familiar with the format. But the first question will be, or similar questions are given as the first question and the last question. In between you get various types of questions. So I am sure with that you have a good understanding of this particular O-Level 2021 paper 1. In the next chapter, I will start and discuss the paper 2 with you all.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.